Okay, we're looking at sine and cosine. These are trigonometric ratios. Okay, here's the definition of the hypotenuse. It's the side opposite the right angle in a right triangle. So you find this right angle, and it's that side that's farthest away, not the ones touching it. Those are called the legs. The hypotenuse is on the opposite side. So from here, it'd be over here, and from this right angle, it'd be over here. Okay, so is this the hypotenuse? Yep, here's our right angle, so that's going to be the one opposite it. This would be a no, because my right angle is right there next to it. That's a leg. That's a no. Here's my right angle. It's right next to it. Okay, sine. The sine of an acute angle of a right triangle is the ratio of the length of the opposite leg to the length of the hypotenuse, okay? So ratio, remember, it's just a comparison of two numbers. The top number is the opposite leg, and the bottom number is the hypotenuse. So if I'm looking from B, which is right here, okay, the opposite leg is this one way over here, so I call that AC, and then of course my hypotenuse is the one opposite my right angle, so that's going to be the one over here, which is AB. If I'm looking from A, sine of A, that means I'm looking from here, so the opposite of A is this one over here, that's BC, which I called it there, and the hypotenuse doesn't change, okay? That's going to be AB. So in the triangle below, what is the leg opposite angle A? So from here, that would be BC. Opposite angle B, it's going to be right there, it's AC. The leg opposite angle A is right here, so opposite would be BC, the one farthest away from it. Okay, opposite angle A, the one farthest away is way over here. That's BC. Cosine, all right, it's the cosine of an acute angle of a right triangle is the ratio of the length of the adjacent leg to the length of the hypotenuse. So again, it's a ratio. This time, instead of it being the opposite leg on top, it's the adjacent leg. That just means the one right next to it. So if I'm looking from A, the adjacent leg is going to be the one right next to it, so right here. All right, so that's AB. And the hypotenuse, again, is always the one opposite from your right angle. All right, so that's going to be AC. If I'm looking from C, the adjacent leg is this one right here, BC. And then the hypotenuse, again, is right there at AC. So in the triangle below, what's the leg adjacent to angle A? So next to angle A, it's going to be that one. AC. It's not this one because that's your hypotenuse. Okay. Adjacent to angle A, that's going to be this one right here, AB. Adjacent to angle C, that one's right here, so that's going to be BC. It's always the leg, okay? Never the hypotenuse. We're looking for the leg adjacent. Okay, here's angle A, the leg adjacent is going to be AC. So the leg opposite is over here, and then this is your hypotenuse. It just depends where you're looking from, if it's opposite or adjacent. Okay, write each ratio as a fraction and as a decimal rounded to the hundredths. Okay, so sine of L. So from L, sine means opposite, so opposite is over here, so that's going to be 7. Over hypotenuse, okay, is always the one opposite your right angle, so in this case it's 25. Okay, and then we're also supposed to give that as a decimal, so I'm just going to go 7 divided by 25, and it's 0.28. Okay, all right, from N, sine is opposite, so opposite from N is over here. That'd be 24. Over hypotenuse doesn't change. That's 25. So 24 divided by 25 is 0.96 as my decimal. Cosine of L, cosine means adjacent over hypotenuse. So from L, the adjacent leg is right here at 24, and it's over 25. And then cosine of N is adjacent. Adjacent is 7 over hypotenuse is 25. And I'm sure you noticed that sine of n and cosine of L are the same fraction and the same decimal. Sine of L and cosine of n are also the same decimal. That should happen, okay? Because we always have hypotenuse on the bottom, and it just depends where you're looking from, if it's opposite or if it's adjacent. Okay, so let's try that again with a different triangle. Let's change that to white. Okay, so sine of A, so from A is right here. Sine means opposite over hypotenuse. All right, so opposite from A is 8 over hypotenuse, which is 10. Well, that reduces to 4/5, which is going to be 0.8. Cosine of A, so from A, the adjacent leg is the one next to it. That's 6 over my hypotenuse, which is 10. That reduces to 3/5, which is 0.6. Sorry about my pen there. Sine of C, okay, so from C, sine is opposite over hypotenuse. Opposite from C is 6 over hypotenuse, which is 10. So again, that's 3/5, which is 0.6. And cosine of C, that's adjacent over hypotenuse. So adjacent to angle C is 8, the one right next to it, over my hypotenuse, which is 10. Reduces to 4/5, which is 0.8. And again, these two match, and then those two match. Okay, let's just skip that one, we just did it twice. Okay, let's see where this is going to apply in real life. Okay, it says to be used safely, a ladder should make an angle of about 75 degrees with the ground. All right, so right in here is 75 degrees. What's the maximum height that a 12-foot ladder can reach safely when it's leaned against a building? All right, so if this is my building, okay, whatever, and this is a 12-foot ladder, so this is my ladder leaning against the building, and we want to know how far up the building we can reach, so we want to know this length right here, okay? All right, this is where your calculator is going to come in handy. You're going to need the graphing calculator, all right? What we're going to do is we're going to look from our angle at what we've been given and what we're trying to find. So we have H and we have 12. Well, this is my hypotenuse, all right? And then from this angle, this is my opposite side. Well, opposite over hypotenuse, that one was sine. So we're going to start with sine, okay? That's how we pick if it's sine or cosine, depending what's given to us. So sine of our angle is opposite over hypotenuse. Opposite is H, we're trying to find that, over the hypotenuse of 12. That's what we're going to start with. Okay? Now you're going to need your calculator. Okay? There's a key. I don't know if you can see it on this one. It's not very bright. All right, but there's a key on here that says sine right there and cosine. That's the two buttons we're going to deal with. Okay? So if I take sine of 75 equals H over 12, well, if I want to solve that for H, I could multiply by 12. That's going to cancel that out. So in my calculator, I'm going to go 12 times sine 75. And that's going to get us our H. All right, so if we want to try it on the calculator, we're going to go 12 times sine 75. And that's 11.59 if I'm going to round. Okay, that means that we can reach 11.59 feet up the wall, if all this criteria is there. Okay, here's another one. We got a wheelchair ramp making a 4-degree angle with the ground. Okay, so here's our wheelchair, okay, and it's a 4-degree angle, so this angle right in here is 4 degrees. The beginning of the ramp is 366 centimeters away from the end of the ramp. What's the length of the ramp to the nearest centimeter? So this is 366 centimeters, and we want to know the length of the ramp, so that right there. All right, so from our angle, we know this is the hypotenuse, and from this angle right here, it's the side right next to my angle. or adjacent to my angle. So between my two choices, I have opposite over hypotenuse or I have adjacent over hypotenuse. This one's right next to it, so I want this one. I want adjacent over hypotenuse, which is my cosine. All right? So cosine of our 4-degree angle is going to be adjacent over hypotenuse. My adjacent is 366, and my hypotenuse is r. All right, now the difference between this one and the last one, all right, this one had the number on the bottom, so we could multiply by 12. On this one, what we're going to do is we're going to take 366 divided by this. Okay? So if the number's on the bottom, you're going to multiply to find your missing number. If the number's on the top, you're going to divide. So in my calculator, I'll change my color. 366, we're going to divide by cosine of 4. And that's going to get me my r. Now, if you want to know why, it's all algebra. Just call me over and I'll explain to you why. Okay? But basically, if you just remember that if the number's on top, we divide. And if the number's on the bottom, we multiply. So in my calculator, all right, again, so I'm going to go 366 divided by cosine of 4. And that's going to get me 366.89. 366.89. Okay, which makes sense. Our hypotenuse should be longer than our leg. It's not much longer, which it shouldn't be anyway because I have a tiny little angle here. Okay? All right, here we've got another one. We've got the sail is in the shape of a right triangle. The longest edge of the sail is 18 meters. Well, of course, we know that would be our hypotenuse. Find the bottom edge of the sail, call the foot, we'll just call it F then, to the nearest meter. Okay, so from our angle, this is the adjacent side. Okay, if they gave us this one or wanted us to find this one, that'd be opposite. Then we would use sine. But because they gave us the adjacent, we're trying to find it, we want to use cosine. So cosine of our 62-degree angle is going to be adjacent, which is F. Ugh, God, my pen is even worse. Over the hypotenuse. Sorry about that. All right, so from what we just learned, if the number is on the bottom, we're going to multiply. So in my calculator, I'm going to go 18 times cosine 62. And that's going to get us our F. So F is about, okay, so in our calculator, all right, so we're going to go 18 times cosine 62. So I get 8.45. Okay, and remember I'm rounding, all right, so I'm going to write my approximately equal to symbol. All right, let's do one more like this. We've got Joey flying a kite. His string was 30 feet long, so let's draw that in there. Okay. All right, so here's our string. Your friend's little brother Joey wants to fly a kite with you. His kite string was 30 feet long. If Joey's standing directly under the kite when the string was let out, so Joey's standing here, okay, he's standing right under the kite. You're over here, helping him fly the kite, okay? If while you're holding out the string you make a 52-degree angle with the ground, so this is 52 degrees right there, how far is Joey from you? So he's over here. We want to know how far is Joey from us. Okay, draw a sketch, just did that, label the information given and show your ratio. Okay, so from this angle, we got this one right here, which means it's the one next to us, adjacent, which means we're going to use cosine of our angle equals adjacent, which is x, over hypotenuse, which is 30. Okay, and remember the number's on the bottom, so that means I'm going to multiply. So in my calculator, I go 30 times cosine 52, and that's going to get me my x. Sorry about that. All right, so 30 times cosine 52 gets me 18.47 about. Okay, so that means he's standing about 18, almost 18 and a half feet away from us. All right, let's stop there for now. I'll walk you guys through these two in class, okay?